as powerful as the consulting experience has been, and I've done that for many years too, there are certain things that just...
This episode of KNN was brought to you by Pandio. More on them in a little. Today, I had the pleasure of speaking with Keith McCormick. Keith is an independent data miner, trainer, speaker, and author in North Carolina, whose LinkedIn Learning courses have been viewed over 500,000 times. For the last several years, the focus of Keith's work has been to improve how analytics leadership runs their teams and how they actually hire and nurture new talent. Keith started his analytics journey as an SPSS instructor, and in this interview, we talk about the rise and fall of that software. We also talk about his thoughts on the future of machine learning tools and his ongoing fascination with personality types. I hope you enjoy our chat. Keith, thank you so much for coming on the Ken's Nearest Neighbors podcast. We've had some really awesome conversations in the past about how people learn, what people are learning, and kind of the data science space in general. And I'm really happy I could bring you in to kind of share your thoughts on these things and maybe change the perspective on how people view learning this data science, machine learning, AI field.
Yeah, absolutely. I've been looking forward to this, and it'll be fun to compare notes as well. We know a little bit about each other already and how we learn, but it'll be fun to, talk some details about that.
For sure. And so the first question I really like to ask is, when did you first get interested in just analytics and numbers and in model building? Was it something that happened like from a pivotal experience, or is it a long drawn out kind of courting this field and falling in love with it?
Well, if one of the choices is, like high school or something, it wasn't that, certainly on the stats side or the math side. I mean, I did fine in those classes. I survived, but I never really felt inspired. I did like playing around on my Commodore 64. Somebody was just asking me what programming language I started out with. I certainly wasn't doing machine learning stuff. It's just, you were doing the most primitive things there. I mean, think it's the Apple Watch that I just got last week is more powerful than a Commodore 64 is by orders of magnitude, right? Yeah, so there was a little bit of interest in programming early on, but funny memory I just had though, I did remember buying Society of Mind in high school. I don't know, that's an old book now, that's like 80s, but that was Marvin Minsky's like AI book. It was just basically about, is it possible to build up something like the brain from like little tiny components? So there must have been some hint that I was interested in that. And I remember reading, there was a book that came out in the 80s too. I graduated high school in 86, so this was all around the time. There was a book that came out on the 7 intelligences. In other words, the idea that there wasn't just like one kind of intelligence, that there were other kinds of intelligence too, like what artists have and, even like athleticism and so on, right? But, kind of looking at that because people knew more about the brain and stuff as things were going along. So maybe little hints, maybe little bits and pieces, but, I certainly wasn't doing data science kind of stuff then. In my first experience with stats in college, not too inspiring, not too exciting. I did have to do an undergraduate project that prompted me to learn SPSS statistics, the software that's been around forever, but in support of the project. And then stats started to get more interesting because the project was interesting. But I didn't really start doing machine learning until my late 20s. And what had happened was I thought I would do a PhD in psychometrics. Psychology and stats. It's actually why I moved to North Carolina, where I still live. And I'd been using SPSS that whole time since the project that I just mentioned in my late 20s. So I'd already accumulated quite a few years of experience. And I had taken some classes in SPSS from SPSS Inc. In other words, corporate software training classes. And I got to know the trainers, and they had been having a heck of a time hiring the right trainers. They'd either have trainers whose only experience was, hands-on at work, but didn't know the theory that well. Or they would try to hire professors that wanted a side gig, a little side hustle. And they rarely worked out either because they were too academic and they hadn't done projects in a corporate environment. So the more they got to know me from taking these advanced classes that I was taking, they just thought I'd be a really good fit. So that was a cool opportunity because I thought that would be a fantastic side gig during grad school. But I enjoyed it so much that it ended up being like 40 weeks a year, which obviously killed the idea of grad school, and traveled all over the place. So it was a lot of things, I guess, hinted at it earlier on, but then I was doing like all stats all day. So I still wasn't doing machine learning, but a couple of years after that, SPSS bought a much smaller company that made what was then called Clementine. And that's what, through many years of evolution and acquisition, became IBM SPSS Modeler. That's what it would be called now. So I was one of the earliest users of that in the US, because the company had been brought over from Europe.
That's awesome. I love that, initially there wasn't necessarily that spark, but it seems like through repetition, through finding uses for the software, is where you really fell in love with it. And I mean, honestly, I had a very similar experience. So in college, I changed majors like 6 or 7 times. I did not know what I wanted to do. And for each of the majors, I had to take a different statistics course. So psychology, you have to take research methods and statistics. For health exercise science, you had to take a stats course. For business, you had to take a stats course. And for environmental science, you had to take a statistics course. So I took 4 statistics courses. I later found out that I had to, that I didn't have to. I could have just used a couple of them to overlap, but story for another time. But by the time I took the 4th course, 1, I was really good at basic statistics. And 2, I'd done a project in each one of these courses. I saw how useful it was. And that's what got me excited about it, right? It wasn't that, I learned the same stuff over again. The beauty of statistics, the beauty of computer science, the beauty of coding is that these are things that you can apply to really interesting problems. Like fundamentally by themselves, they're not that interesting, but to some people, they're not that interesting. Some people, they're completely fascinating. But when you take these things and use them as tools, I mean, you can do incredible things. You can understand the world in ways that you'd never have understood it before.
Yeah, it's funny. We have more in common even than we realize, because I changed major probably 4 times. I was on an Army scholarship, so I drove my colonel crazy. I mean, this wasn't just, I go to the college office and fill out the form. This was like I had to get the Army's okay to like change major. They were they were just beside themselves, every time I made these changes. But what you're saying really resonates with me, because the first stats class that I took, and I feel kind of bad looking back that I didn't cut this guy more slack, but I was 18, 19 years old, whatever. But he had us take this string and like measure eggs, like the width of the egg and the height of the egg, which, looking back, was kind of cool what he was trying to do. He was trying to make it hands-on, but it was eggs. There was nothing real world about it, So I didn't feel like I was solving a problem. He was just trying to make it, a very tangible way of looking at like mean and median. And I just wasn't into it, But when I was doing that real world project, then I got excited about it. And frankly, and I bet we have this experience in common too, it really sinks in a big way when you teach it. I mean, you think you know it, but now you're going to be in front of 20 people, or, in your case, a little bit different. You're in front of a heck of a lot more than 20 people, but they're not always in the same room with you. I mean, they both have an interesting dynamic. But I would be almost every business day in front of these folks teaching the software, and the concepts part of it was a big part of what we would cover. So the pressure was on, and I never did get an advanced degree. So I thought for sure I was going to get that PhD, and I was just postponing it. But after many years, it's been 25. Now more than 25. Obviously things have changed, but I always thought I'd go back, but I would frequently have PhDs in my classes, because they might have known the theory but been switching software. That was often why I had them. They were often SAS users, which at the time was SPSS's biggest competitor. Between the two of them, it completely dominated the space. R was not a thing yet in the late 90s. Python existed, but it wasn't a machine learning thing. So the two big players in both the statistics space and the machine learning space were SAS. So I would get these SAS folks, had been trained in SAS, I don't mean SAS employees, that had a new job or something. I live in Raleigh-Durham, North Carolina, which is about 5 hours drive to DC. So I would frequently be the DC trainer. 1 week a month, probably, I was in DC. So you can guess the kind of folks I had. Department of Labor, AARP, IRS, all that kind of stuff. So sometimes when they switched departments, they had to switch software. So I remember the third time that I taught regression, I had in my regression class. Now he was like 60 at the time because Tukey had passed, but this guy had gotten a PhD with John Tukey, the guy that a lot of tests are
Tukey
named
tests.
after.
Yeah.
Yeah, exactly. That's the guy. So here was the guy that had taken grad stats with Tukey many years earlier. But again, it was because he was learning regression. But this class, I had to review the theory too. So he introduced me during the first lunch break, and I was terrified. I mean, I felt like I really knew my stuff, but somehow I got all I got kind of all funny since I'm such a huge fan of Tukey. But he complimented me at the end, and that was a big confidence builder. But that's what I mean about the adrenaline rush each night. Even though some of the stuff I was teaching pretty basic, I felt I really had to be on the top of my game teaching those classes.
Oh, I could not agree more. I feel like, you never want to, there's that additional social pressure. Like, at the end of the day, it's okay if you make a mistake, but you don't want to, right? You want to provide the best information. You want to make sure that you're doing your research. And that's part of the fun of teaching. I mean, in college, in grad school, I loved study groups because I would always try to be the person that taught the material to the other people. Because again, that's when you prove to yourself that you know it. It's when you can really, make that extension beyond just like the general ideas that you're working with. That's the applied knowledge to me. Now, a quick word from this episode's sponsor, Pandio. Taking advantage of machine learning doesn't just mean that you have a lot of data. It means that you have the ability to access, to query, and to move that data in a seamless manner across your enterprise. Pandio is the only data orchestration layer that enables you to connect different data sources, query data in place as if it were a single database, and move that data at scale. Let your data science teams focus on optimizing the models for data-driven decisions, and let Pandio focus on the logistics. Go to pandio.com, that's pandio.com, for a free trial to see how Pandio can drive massive value for your data transformation. Now back to the episode. I'd like to hear more about your experience with teaching to begin with. So obviously you're teaching the theory, obviously you're teaching SPSS. I'm interested in the first thing, like what you loved most about that, and what you learned as a teacher. Aside from just the understanding the platform and the theory better, what else did you take away? Were there things you learned about yourself, or were there things you learned about students?
Well, there's an interesting detail about why I was even at these SPSS classes that's interesting. I had this long-term research gig that I was doing from home. That was my first remote job. And so I said, I was half-time, and I talked to my boss and said, if you're willing to pay for what they call this training subscription, I could get an unlimited number of SPSS software classes in a calendar year. And I told my boss, I said, look, I'll do it on my free time. And if there's any travel involved, I'll pick up the travel. So that was a good deal for both of us. So we did it. So I took a bunch of these classes. That's how they got to know me. So what was powerful about the experience is that around the same time, I hadn't given up on grad school yet. So I took a regression class for the psych grad students at Chapel Hill, because that's where I thought I was going to enroll. And that, that sucker ran 10 months. That was pretty intense. But also I was getting a chance to practice some of these basics, not as high as level as that class. But here's the amazing part, because I anticipated this about you, that you would have during grad school and various times had times when you were doing like kind of the classroom thing with other people too. But what was remarkable about that time, which I just don't think people would get a chance to experience anymore, is that I would be teaching something like that 3-day regression class every 6 to 8 weeks for 15 years. So just the number of people I met, and it wasn't at all infrequent that there were grad students in there that were doing their dissertation and wanted to sharpen their skills. So think about how many dissertations people told me about during their lunch break and little problems that they were solving. And that eventually, switched over to consulting. But it's also the environment in which I learned the machine learning stuff. Because when SPSS acquired Clementine, they had these folks that had been using Clementine for years that came over from Europe, and I sat in on their classes, sometimes 3-4 times, because I might be teaching Monday through Wednesday, and maybe this class was going to be held at the end of the week, and I would stick around. So that was a powerful experience. Not only seeing the stuff once or twice, but multiple times, and having all of these lunch conversations about hundreds of projects. And next thing you know, I had taught thousands of people this stuff.
Awesome.
Face to face.
Yeah, I mean, I guess we really lose out on that with the online learning to a certain extent. You don't have that additional layer where you can meet the teacher, you can ask these additional questions, which is a sad thing. I mean, obviously online learning has plenty of excellent benefits, and you're a part of the online learning as well. What has been, aside from the interpersonal stuff, what has been the biggest kind of surprise for you there, or what have you liked about it? What have you not liked about transitioning to a lot of online learning?
Oh, well, I think you framed it exactly right. I think what you kind of miss is the 15-minute breaks and the lunch break. They don't seem like they're a big deal, but that's where you hear hundreds of what they're doing at work. Whereas, online creates a little bit of a distance between all of us, you know what I mean? So I'm sure you get endless chats, comments, direct messages, emails, and so on, but it's not quite the same as somebody saying, Keith, could we, I'd love to talk to you about my dissertation. Could we have lunch? And then I don't know about you, but I get pretty wiped out like when I'm teaching. So usually I'll be exhausted. I'll go, oh, how can I turn them down? They're talking about their dissertation. You know what I mean? So I grab a little bit of extra caffeine and do it. So it's hard not to miss that. That's pretty powerful. And they get to meet each other, which of course you don't quite have the equivalent of. You can have a Slack channel. There are various ways you can try to imitate it, but it never quite feels the same. But I mean, come on, it's pretty rewarding to know that you're reaching 100,000 people. Impossible in a classroom, 20 people at a time. I know when Gladwell's Outliers book came out, the famous 10,000 hour thing. And I just scribbled, I scribbled on a scratch pad, and I said, wonder how many hours, I've been using SPSS. And I got to this crazy number and just decided I wasn't going to figure it out anymore. It just seemed ridiculous. But I did a rough back of the envelope, and I had about 10,000 classroom hours. Again, just cycling through like these 30 courses again and again. And as powerful as the consulting experience has been, and I've done that for many years too, there are certain things that just are kind of like in my bones now that I probably would have never felt that way if it wasn't for that huge volume. But think about it. That meant that it took me 10,000 classroom hours to reach several thousand people. Whereas, online, several thousand people a month might be seeing, my material. So it brings the conversation to a different level, but it's a different kind of conversation. They're both rewarding and powerful in their own way.
Awesome. So I have a question that's a little tangential, but it's about SPSS and transitioning away from that. Obviously, that's something you did for a very long time.
Sure.
And, frankly, I think SPSS is really only used in academia still, and I kind of think it's on its way out at this point in time. What has that transition been like for you? Obviously, we've talked, you're primarily an R user, correct?
Yeah.
Do you think that that's necessarily a good thing? It seems like things went from SAS, which was almost SAS and like MATLAB, which was kind of programmatic, to SPSS, which is like a GUI, to R and Python, which are just like pure programming languages now. I think that that's fairly interesting, where it's like we went more basic to more functional, back to more basic again. Do you have any thoughts on kind of that whole pipeline and your learning process around that?
I'm actually I'm kind of more of a NIME guy now. Here's my Nime coffee mug. And folks might not even know what Nime is.
I don't know what Nime is.
Yeah, I'll have to explain. I'll have to explain what Nime is, but I want to answer your. So let's both remember to come back to that. But let's just talk stats here for a second. So SPSS and SAS are both about the same age. And I'm about the same age. SPSS came out in 68, which is my birth year, and SAS came out in 71, I think, if I'm not getting the years mixed up. So for quite a long time, if we're talking like punch card days, that was it. It was those two. By the time you get to my undergraduate career, would have been late 80s. I graduated in 91. If you're talking then, you've got SPSS, SAS, MATLAB, Minitab, and a few others all coexisting. R wasn't quite a thing yet, okay? So you asked me about the transition from SPSS. Well, I've written a bunch of SPSS books. I've got a stack of SPSS books over here. I've written 4 of them are mine because somebody was just interviewing me about the books. And some of them are actually fairly recent. So I still think of myself as part of the SPSS community. But the trick with SPSS, you're going to remember there's 2 versions of SPSS. There's what people used to call SPSS is now called SPSS Statistics. And what used to be called Clementine, that software that I was telling you about that some people might not know, is called SPSS Modeler. So SPSS is really the stats package and the machine learning package. So the quick version is in 2009, IBM bought SPSS. And SPSS went from being the #1 dominant product line of a $500 million company to a rounding error in a huge company, right? And I knew that my career was going to change, but I think this experience is one of the reasons why I tell folks to not fall in love with R, Python, or whatever, because, if you're in this game, depending on how you start counting, I'm between 25 and 30 years now, depending on, you kind of start with the machine learning stuff, or if you want to start with consulting, maybe it's more with like 20 years. But if you start with like those earliest stats projects and my first mastering of SPSS, it's like going on 30 years, things will change. So in 2009, this was like a crisis. This was like, I know things are going to change. I don't think SPSS is going away, but I'm not quite sure what my relationship's going to be to IBM. Boy, does that mean that I have to learn something new? And I think a lot of people fall for that trap. They throw all their energy into one thing, thinking that they're going to get a whole career out of that. And I can tell you it's not going to happen. So I panicked probably a little bit more than I had to. It was a while before things changed, but I suddenly realized that it was all for the best anyway. I had been knocked out of my complacency a little bit, and it was about time at that stage in my career that I start working with analytics leadership and not obsessing over the tools anyway. So the IBM acquisition of SPSS kind of shook up my life a little bit. But again, at the time, I was thinking, wow, I've got tens of thousands of hours in SPSS statistics and SPSS modeler. What would I ever do if that wasn't my career anymore? It was like a panic. And looking back, it was all very silly, Yeah. And it turned out to be, I thought it was going to be this sudden process. It turned out to be a very slow process. I started to do more and more project leadership, and I was less hands-on anyway. So I really had nothing to worry about. And Nime is an open source predictive analytics workbench. Just showing that because I got my pen stuck in there on the desk here, but it's a great piece of software, and it's an open source. It's not like an open source version of Modeler, but it physically resembles Modeler, as many packages do. Alltrix, Data Robot, Nime. There's a bunch of them that really think that's a great way when someone's starting out to play around with software like that, because it's less of a barrier to entry, and it gets you working on, actual models and actual concepts quicker. And then when you've got your sea legs, then I think you would agree at this point, Python is the way to go and not R. But 5 years ago, there was a big debate over R and Python. But that's the quick story on that. So it caused this brief panic, but looking back, it was all very silly. I should have been working in 3, 4, 5 different tools concurrently anyway. That's the way everybody should be.
Yeah, I mean, honestly, I love that story. I really respect you for being able to make a transition, um, and kind of getting out of your own head about it. I know you're doing this for a long period of time. It's like, well, crap, what do I do now? Um, but I also think that there's some beauty in how all of the ecosystem works together. If you understand how SPSS works, it's going to be easier for you to understand
Yes.
how, like the basics of R, which means you're essentially going to understand the basics of Python. And I think that that's something people don't realize is they get so wrapped up in what they should learn first. Oh, I don't want to waste time learning XYZ because, I might not use it. My thought is that if you learn one thing pretty well, there other programming languages are a lot easier to learn. Like I started with learning Python, and then I learned some Java, and then I had to, for a course, learn C. But C was easier to learn for me than Java was, and Python was the hardest to learn for me to start with because I didn't have any foundation to build it off of. So after I learned Python, Java was a little easier, C was easier, Scala was easier, and then it keeps getting easier because you have this model of the world to work off of. And
I'm, I'm,
so
I'm smiling because I was chatting with somebody. It was on another podcast recently, and um, just got an audience question. It happened to actually be a live event, and somebody asked as an audience question. They said, "Hey Keith, what was your very first programming language ever?" Right, and that's what I was reminded of. Basic on, on the Commodore 64, and then when I was a freshman in college, I learned Pascal, which was then a thing. I get the magazine of the Association of Computing Machinery because I go to the KDD conference, and there it wasn't on the cover, but somewhere there was a big article in there. Pascal is 50 years old, this year, which I thought which was funny. I didn't know that. And then the third language I learned was Lisp. Do you even know what Lisp is?
I actually had to do some Lisp
Oh,
in.
right.
Uh, I,
Obviously that's fading
yes.
in popularity.
Well, so we used it in a concepts of programming languages course,
Oh, cool.
and so we used that, I believe, to learn about functional programming because I think it's a functional language, if I recall correctly.
Oh, I can't remember. All I
Yeah, I
remember
can't.
is we used to, or its nickname was lots of silly parentheses. That was
Yes.
when I was like 18. We would, the other memory that I just got actually learning programming, that I don't talk about this as often as I should because I think it's really powerful. Because, well, look, we're kindred spirits on this whole don't obsess over the tool. You're going to have to learn more than one tool because you must get that question at least as often as me, and probably many times more because you've really, built up a following, on your days of data, series. So I think you build a real relationship with your audience that perhaps I haven't quite yet because I have some people that discover some of my classes and don't even discover the other ones. It's just something about the platform or whatever. But uh, what was I going to say about? Oh yeah, about switching languages that they just kind of have to, let that go. But the memory that I had was when we would take a computer science concepts course, could be a database design course or something like that. We could choose any language we wanted. And I always thought those poor teaching assistants there's like 12 of us and we're submitting homework in 12 different languages. What a pain in the neck for them, right? But it's because one, the professors weren't grading, so what did they care? Right? The other reason was they thought it was beside the point. They didn't want to spend any lecture time. Since I was a major, in fact, when I took that first Pascal class, I think it's because I was biology major for about 5 minutes. And that's why I took that introductory class. We were discouraged as computer science majors to take any language classes. It was pretty much verboten. Maybe we could get away with one. If we did any others, it was like on our own time. We were expected to teach ourselves the languages. So when we went into when we went to the class, it might be something like, write me an efficient loop or something in any language you want. Don't waste my time talking about languages. It was just considered not a good use of class time. So who knows? Maybe that memory sticks out of my mind too about, this whole obsessing about it. The metaphor that comes to mind too, I bet you'll get a kick out of this, is that to me, it seems like market timing. Not that I don't think trying to market time isn't fun. I'm not really a quant, but when people try to say, what stock is going to do great, or trying to do arbitrage, if you're trying to guess where to put all of my effort into one software tool or one language, it's like you're trying to market time. It's like you're trying to say, by the time I'm trying to get a job with somebody, this is going to be the one skill that I need. That's why people obsess over that question, because they think it's reducible to that, which it is not.
Yeah. Well, the thing for me is every couple weeks, every couple months, I have to work with new tools, right? Whether it's a new package a new module that I'm learning on Python, whether it's something else altogether. I mean, that learning never stops in the profession, and there's no reason why we should, take that. We shouldn't take that to the base level with the programming language, right? And I think that's a really interesting thing you mentioned with how programming or the computer science concepts used to be taught. I mean, I don't think many schools do it that way anymore, but one, it would be very difficult to get people like excited about starting because they'd be so scared. But I think if you're talking about people who are already experienced with some programming languages, that's definitely a better way to teach. And none of my courses that I teach am I going to take that approach, but I understand it. It probably was incredibly helpful and valuable to a lot of the students. Again, some of the students might have just quit the major because of that, but or the teaching aides probably all quit.
Well, the teaching assistants, yeah, they were really, they were really made the pack mules by the professors. They were the one that were, the professors were trying to offer some flexibility, but they were the one that got hit with the extra work, right? It's funny though, because I do some teaching for UC Irvine and their continuing ed program, the whole variety of certificates they have. They have a predictive analytics certificate and a data science certificate and so on. And I will let, usually I use KNIME as the tool. And the reason that I do is because I'm asked by the university not to spend any time on tool training. So they have to learn the tool on their own. And being required to do assignments in Python, but not having a Python class, I think is kind of tough,
No,
So in the certificates that are lengthier, that get more technical, they do start with a Python class and then they go from there. But I teach in some certificate programs where there's only a half dozen classes. So, they kind of learn KNIME on their own, which isn't hard to do. But then then I'll, I do forums where I give help on that tool as needed, but not a lot of lectures on it. The lectures are on the concepts. But then when they turn in a capstone, or even when they turn in a homework, I don't care if they turn in something they did in Tableau or whatever, as long as they do the assignment. And when I'm on advisory board calls with other instructors, 80-90% of them have the same policy.
Very cool. Well, I'm actually teaching my first university course in the upcoming months, so I'll take some notes. I don't think there's going to be any programming at all in it, but I do realize that I get teaching aids, so that's something I can think about how to best allocate their time. So
yeah,
as well. So I think we're coming towards the end of a couple more questions. The first, though, is about your teaching philosophy. What do you think is a compelling way to teach data science, machine learning? We've talked a lot about theory versus practice, and I'd really like to get your thoughts on that.
Well, I'm going to mention one more thing about the SPSS training thing. I mentioned SPSS is an acquisition of Clementine. So a couple of the folks that came over in acquisition, really by coincidence, because it had nothing to do with the software per se, but they had been part of the project to write CRISP-DM, the cross-industry standard process for data mining, which is the famous, even if people don't know it by name, it's the famous business understanding, data prep, steps in the data mining process.
There's like the awesome model as well. And then there's one or two other ones, but continue.
Yeah, no, absolutely. And, I'm going to make note of the awesome model because I'm always wondering about the new variants and I haven't heard of them all. But
it's spelled OSEMN. I'll actually link an article below to this podcast. It's one my friend, the data professor, wrote, and he goes through all of the main models that are out there right now.
Oh, awesome. And then we can link to CRISP-DM as well. But anyway, since those folks have been part of that project, and happened to also be employees of the company that made Clementine. So they, a number of them, including some folks that are, pretty famous, at least in certain circles, they, the lead authors of it, they were all hanging out in the SPSS offices because they had relocated to the US for a couple of years to facilitate the acquisition. So I've always been a huge fan of ChristyM. And for me, ChristyM is a much bigger deal than people give it credit, because they wrote that thing over like 3 years. There were 200 organizations involved. So this wasn't somebody sitting down with like a legal pad and kind of like rethinking, it drawn from their experience. There were workshops. There were even like little mini conferences. There were surveys that went out, and big companies like NCR and Daimler Chrysler and stuff like that were involved. So it was really something. So for me, that was the setup to answer your question about my teaching philosophy. I think it's so important to try to impart some of the things that I've learned seeing dozens of projects from start to finish. And this is kind of the topic that got our initial conversation going, because I think things like Kaggle competitions are so amazing. I couldn't be more supportive of what Kaggle is trying to do and people that participate with that. But it's a lot of practice on the modeling phase with a little bit of data prep sprinkled in, and at some point you've got to see that bigger picture from problem definition at the beginning, which in a Kaggle competition has been done for you. That's the competition description. That's the end of the, that's even Tony Goldblum, the founder of Kaggle, will say that it really only covers about 30% of the process, a very valuable one, right? But it was never intended to be the whole thing. And naturally, you can't do business evaluation. You can check to see how accurate the model is. That's the whole point of the competition, but you can't really see how it brings value in a business. You never get there. Maybe on occasion the winners are invited to interact with the client. I wouldn't be surprised. Sometimes the winners become like, these grandmasters, and they get to be on advisory boards and speak on panels and so on. They may get some insight to that, but most people don't. And of course, you don't see the thing deployed. So that's an extremely important part of my teaching philosophy. So in the UC Irvine certificate program, we literally have a course per phase of ChristyM. And sometimes the courses change a little bit each year, but when they were originally designed, at least, there was a course on each phase. And I think that's really powerful. So that also informs my LinkedIn Learning courses. I always look through the library, and generally I find a ton of really good Python and R content. So I try to fill in gaps that I think that, that I detect there, that for whatever reason haven't been put in the library yet. And there's a lot of problem definition. There's a lot of strategy. There's plenty of modeling in there. I've had some courses that have a 2-course series on just decision trees, right? But I also try to insert a lot of high-level strategy, for the practitioner in there, and that's critical to my teaching approach.
That's awesome. I mean, I 100% agree with you. I think the beginning of the process and the end of the process are the most overlooked portions, and they're probably the most important part, right? So let's start with the beginning of the process. If you have bad data coming in, if you don't know where it's coming from, if it's messy, if there's noise, whatever it is, no matter how good your model is, it's still going to be bad because of the garbage in, garbage out concept. And if you think about the end, the way you make your model useful to someone else is all that really matters, right? If you build the best model in the world, but no one can use it, it's completely useless. So the way you put it into production, the way that you make an interface out of it, whatever you eventually use it for, again, it is completely useless without that step. So to me, not highlighting that part, and I guess Kaggle to a certain extent does have the end portion, but the beginning portion is you can't do anything without data. So how do you either collect it or whatever it is?
I'm going to disagree just with you slightly on the last part. I want to talk about the first. I kind of like the way you talked about them as bookends, but I'm going to disagree with you slightly on the deployment piece. I really don't think there is now you're uploading the model and then they're scoring the model on new data. I get it. But here's where I'm going to disagree with you a little bit. In ChristyM, which again, I'm this huge fan of, that's really the model assessment task. That's really still part of modeling. That's really just saying, does my model fit the test data?
Yep.
Now, granted, you might have train test evaluation data or something that might make that slightly more complicated. But then comes business evaluation, where you have to be measuring things like return on investment,
And
which
that feedback
clearly
loop,
is not possible in a Kaggle competition because you're not privy. You'd have to be in meetings. You'd have to be on Zoom calls with the client really to get even the vaguest sense of that. So you might, you and everybody, hopefully that's listening, might find this interesting. I'm working, as we record this, it's it's in March, and this month I'm working on a course that in its entirety, the whole course, not just a lecture in it, the whole course is on estimating return on investment for predictive analytics. The way that I would do it in the business understanding phase, before I start to build the model, before I look at the data, before I do anything, how do I get a rough estimate of ROI? And I think this isn't irrational, but if people haven't thought about it the way that I'm going to present it, they probably think, gosh, Keith, that's not really possible. There's too many variables. There's too many things you don't know. But if you can't estimate it, how do you even know to approve the project? If you're a VP of analytics or something like that, you have to. And then on the front end, like the data piece, for instance, I proposed a class last year and I was so excited when it got approved because I wasn't sure if they were going to give me a necessary amount of time. I did an entire course on the data understanding phase of ChristyM. So since I didn't think everybody would know what that phrase meant, I called it data assessment. But it's what you were just describing. And it's the second phase of ChristyM when you're looking at all the different data. Is the data sufficient? Is the data complete? Do I have missing data? Am I going to have to impute? Am I going to have to do feature engineering? And of course, the answer is always yes, right? But all these things. So that is a 4-hour class on data assessment, and it's not a data viz class.
It's probably not even enough, right?
What's that?
That's probably 4 hours. Probably isn't even enough.
No, I had to be selective, but it's, one of the things that I did to help is I kept on referring to exactly where I was in ChristyM so people could do additional reading and, look at exactly where I was. But it was just as the name implies, is this data going to get me where I'm going? And if not, the answer is always no. If not, what do I have to do to fix it in data prep? See, people think data exploration is kind of just getting a feel for the data, but it's really a checklist for data prep. It's a to-do list for data prep. Yeah, but you're quite right. 4 hours isn't enough.
Yeah.
So,
And I agree with you. I completely forgot about the actual end of the steps. I always think in terms of the data science lifecycle. But the first step is like business understanding, assessment, problem identification. And then the last step, if I remember correctly, is like the assessment of results, and for the most part, like back testing over and over again, because we never want our models to go stagnant. I kind of chopped off even in my example of the ends there. So thank you for refreshing my memory.
No, you said that well. If they rewrote it now in 2021, they probably would add what you describe as the last step. But the way they originally wrote it was business understanding, data understanding, what I did the data assessment course on, data prep, modeling, evaluation. But evaluation isn't R squared and area under the curve. Evaluation is like ROI. It's like, does it solve the business problem? So I asked Tom Cabaza, one of the co-authors, this. I said, Tom, for goodness sakes, why didn't you call it business evaluation? Because everybody thinks it's this technical criteria. He goes, well, it was kind of obvious to us. If we thought that anybody didn't think it was business evaluation, we would have called it that. But we didn't think anybody was going to think it was R squared. We thought that everybody knew that we meant, does it solve the business problem, right? So understandable in retrospect.
They should have identified their business problem better when designing that.
Well, it was all these people that were doing it got together to reduce it to writing, but they didn't expect the millions of rookies that we are having now, because it was still a small field back then. They didn't foresee, I guess, the explosion that was going to happen over time. So then after business evaluation is deployment, and part of deployment is monitoring, which is that continuous improvement that you were just referring to. And that's a task under deployment, but I think they should have made it a phase. I mean, who cares, task or phase on some level, right? But I think it should be a phase, because usually there's a handoff. Usually the modeler plays some role in deployment, but some other person ends up taking over during monitoring.
Yeah, absolutely. So honestly, those are all the questions I had. This has been awesome so far. At the end of every interview, I kind of open the floor for you to talk about anything you'd like. I would love to hear from you to add a little extra color to our conversations, maybe something you're interested in, some advice you have, whatever that might be.
Sure. So this will be fun because you were telling me offline that your audience asks you about this all the time. So when I said I was thinking about getting a PhD in psychometrics, the reason is because that undergraduate project I mentioned was looking at learning style bias in the SAT, and I was using the Myers-Briggs type indicator as my learning style instrument. That and some others that people probably aren't familiar with, but that was one of the ones in the study. So I've continued to stay interested in this all these years. It's not really part of my day job, but there's a movie that just came out called Persona on HBO Max. So I was watching that with some interest because it's this very spooky dystopian, future of personality tests. Anyway, I'm kind of intrigued with that. So I'm curious what your type preferences are you were saying earlier that people ask you all the time.
Yeah, so for Myers-Briggs, I'm an ENTJ.
ENTJ.
I also I've always been fascinated with personality assessments. I will say I've also seen like the biggest problem with them is that they're definitely situational. So in my mind, if I'm in a presenting setting, any of these things, I'm far more extroverted than I normally am, although I am still baseline extroverted. But I kind of revert in the level of extroversion or judging or feeling or whatever those are, more towards the mean. But in certain scenarios, I am extremely one direction. Um, you know, I think that the profession you're in, for example, at work, like in data science, you're going to be a lot more, you're going to be focusing more on the analytics and understanding through inference than you are going to be just like in using intuition to get to certain solutions. So on the job, if you're a data scientist, you might be more like that, whereas in your personal life, you might not be like that. So I think that for me is the fun part, is can we understand how these things evolved by situation, and can we even layer that on to make those models more effective? Again, I'm fascinated with these things. I love the ocean one. I use that in every human interaction that I have as well.
Yeah. No, that's interesting, and that's something that comes up in the movie because they talk about Big Five and MBTI as being like Coke and Pepsi. But again, it's a very dark and gloomy film. But if you're interested in all that stuff, you should check it out.
Oh, I
Yeah.
definitely will.
So because that's out, and for some other reasons that are going on, this year 2021 is the 100th anniversary of Jung's book, Psychological Types. I guess it came out in Swiss German in 21 and then came out in English a couple of years later. But anyway, a lot of people are celebrating. People that are into the Jung thing are celebrating that this year. So I find myself talking about that more than usual. And I just kind of lend my stats expertise, explaining stuff like what's Cronbach's alpha and what's split half reliability and what's face validity and stuff like that. It's kind of fun. And my preferences are INTP.
Very cool.
Yep.
We have at least one in common, two in common there.
Well, but they go in different directions. So if you want to get all geeky about this stuff, as an ENTJ, you'd be extroverted thinking,
Yep.
with introverted intuition as your second best, right? So that's really what explains the extrovert introvert thing. I often joke that, when people talk about ambiverts, you don't need a name for an ambivert because you were kind of explaining that you do both. You don't have to have a fancy name for people that have both extroversion and introversion. They're called adults. Because according to theory, by the time you're college age or so, you would have your top two functions, which gives you balance. Because Jung is Jung, right? I mean, he's a depth psychology. He's all into this psychic balance, and Jungian analysts analyze dreams and things like that. So the notion is that your top two functions become conscious, which for Jung just basically means that you have control over them, that you're aware of them, that you feel competent in them. So you have a weight extrovert, and I have a weight introvert. So we both have thinking in common, but your thinking is extroverted and mine is introverted.
Interesting.
And we both have intuition in common, but my intuition is extroverted and your intuition is introverted.
Huh. That is fascinating.
Yeah.
Awesome. Well, again, this was a really cool conversation, Keith. Thank you so much for coming on. And I'm excited to publish. I think people are going to have a lot of really interesting findings. One about SPSS, just like the history there. I didn't know that. It was fascinating to me, but also about your experience teaching, your learning journey, etc.
And don't freak out if like somebody changes your Python library or the field chooses a new favorite. Don't freak out. It's going to be fine.